go, guys. It's opening night, and while we're getting ready to watch the beginning of the game, we're going to do a little pre-lab for Wednesday. The lab for this week is titled Finding the Value of the Ideal Gas Constant. Your beginning question, what is the value of the ideal gas constant? Imagine that. All right, our procedure, step 0, is going to be put on your safety glasses. Step 1, you're going to need a 400 milliliter beaker. Suddenly I've forgotten how to make a 400 milliliter beaker. And you need to fill it with water. And it can be tap water. Step 2, you're going to get a piece of magnesium ribbon, and you want to cut it so that it is about, it's 3.3 centimeters, and you're going to measure it as precisely as possible with a ruler and record. Step 3. Step 3, we're going to do a conversion, and at this point, I don't know the conversion because I don't have the magnesium ribbon or a balance at home, but we will convert the length of the ribbon to mass, because the ribbon is so small that it's very hard to get a mass without using a very exact balance. We don't have one of those. Our balances go to 0.01 and we need about 0.03 of a between 0.3 and 0.4, and so we're going to actually just do it with math instead. Step 4, get a piece of copper wire that is 15 centimeters long. We're going to take that wire and we're going to twist it. We're going to leave about a 7 centimeter tail, and we're going to twist a little cage, and we're going to put our magnesium ribbon in there. So kind of wrap it around your finger, and then you're going to make a little cage, and the magnesium will go inside of it. And I'll help you and show you how to do that on the day of. Step 5, put the magnesium inside of it. Step 6, you'll have a one-hole stopper. Here's the hole. You're going to put the magnesium ribbon in. You want a piece that will hang over the edge, and then that ribbon's going to hang down, and then your cage with your magnesium will be about 7 centimeters below the bottom of the stopper. So you're going to have it hanging below. Step 7, you're going to add 15 milliliters of a 2 molar hydrochloric acid solution. You're going to obtain 15 milliliters. We'll add it here in a moment. And then you will add that into what we call a eudiometer. It's kind of a cool name. Okay, it's basically a very, very large test tube. That is the worst test tube I've ever drawn. Okay, and what you're going to do is you're going to add that hydrochloric acid into the eudiometer. Step 9 then is going to be to add distilled water to the eudiometer and fill it up. So you're going to have a little bit of HCl in the bottom. Now you want to put this in carefully. You want to actually do it with the squeeze bottle, not just pour it in, because you don't want the hydrochloric acid to mix. We want the hydrochloric acid to stay at the bottom, and we want it to fill completely with water. Step 10, we're going to put our magnesium copper wire stopper assembly in to the UDometer. So here's our UDometer. Here's our stopper. And what's going to happen is that wire is going to hang down inside of the stopper. And we're then going to fill the tube through the little hole up with distilled water so that it's completely full. There's no air at the top. Step 11, you're going to put your thumb over the top of that UDometer and you're going to flip it upside down. So like here, if this straw is my UDometer, here, I'm going to put my thumb over the top. I'm going to take it, I'm going to flip it upside down, I'm going to stick it under the surface of the tap water that's in my 400 milliliter beaker, and then once it's under the surface, I'll take my thumb off of it. Okay? So, you're going to take your thumb, you're going to flip it over, there's your 400 milliliter beaker, and your tube's going to be in here, and we want no air to get in if possible. And what will happen after you flip it over, that hydrochloric acid will begin to work its way down, and you'll actually be able to see it mixing because they're different densities, and they actually call that Schlieren, and I will probably talk about that. But you'll be able to see it mixing, and eventually the hydrochloric acid will get down here to our little piece of magnesium, and it will start reacting and bubbling. And what's the hydrogen gas going to do? It's going to rise, and it's going to rise up into the tube, displace the water. The water will come out through the hole, and will collect the gas. Step 12 says record evidence, and we'll make a data table in a moment. Okay, keep an eye on the tube. If you have any magnesium escape, you may need to tap the tube to get it to react. And tap the tube so that the bubbles don't stick to the side. And you're going to let it go for about 5 minutes. The next step, we have 3 500 milliliter graduated cylinders, really big guys. And I'm going to space them so that there's one between each set of lab groups in a sink. We're going to take this tube that's in our beaker. You're going to reach in. So we've got this system going on. Reach in to your tube, pull it out, and carry it like this, and you'll put it right into this 500 milliliter beaker, or 500 milliliter graduate, and I will demonstrate that for you. But basically, this tube is going to go over here, and what we'll be doing at that point, we will be trying to figure out the water pressure and air pressure. We want the air pressure inside the tube to be the same as the air pressure outside. So once the water level in the tube is equal to the level in the 500 milliliter beaker, then we can make our reading on our amount of gas in there and record it, and then we'll have our volume. Alright, that is all we're going to worry about right now. I'm going to make a data table next, and I'll flash it up here in a moment, and then you'll have everything you need. Okay, here's a very crude data table. You're going to need the length of your magnesium. You'll need the mass of the magnesium that we'll calculate using a conversion factor. You'll need the volume of the hydrogen gas collected. You'll need the barometric pressure, which we will get from a barometer. I think that if Miss Rice doesn't have one in her room, I'm sure Miss Epps does down in the geosciences. You'll need the temperature of the water, so you're going to need a thermometer. And we'll introduce an idea of partial pressures in Dalton's law of partial pressures, and we'll figure out the water vapor pressure inside that tube. But we'll do that in class together. All right, that's all you need. And so my plan is to get this lab going on Wednesday. We'll see you then. Bye.